Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. This is actually another special episode. I think this is like the second or third one of these that I've done this year, where I'm actually joined by someone else. This is BoyC of Conspiracy. Am I saying that right? Is that how you pronounce that? That's how by the capitalization, I always assume that's how it was. For those of you guys who don't know who Conspiracy is, go watch all of their intros after this stream. You'll see a couple you'll see a lot of that stuff here. Of course, I'm really excited to share some of these guys' tools. These guys have been doing 64K since, was it 2003 you guys made your debut? And that was Breakpoint with Project Genesis. Yeah, huge intro. These guys are extremely influential in the demo scene and have been for several years. Top-notch stuff. So I'm really excited about this. And yeah, so he's here to share a bunch of stuff about the tooling that they use currently, and also a little bit about how some of their more recent intros have been made with this tooling. So I'm super stoked about this. Oh, apparently BoyC's audio is not coming through. Let's see. This is really normal, by the way, that I have audio issues, so. We may need to add a audio device capture for you. Input capture you want.
Is it better now?
That should definitely be better.
Can people hear me?
Check.
Check.
For the delay a bit.
Testing.
Nice.
1, 2, 3.
And for my audio, by the way, so we're actually streaming this from BoyC's setup. So if I sound a little lower quality than usual, that's just how it's going to be.
Yeah,
from what I can tell, I am using the correct mic, so we should be okay. But this is just what we have to deal with. Anyway, so but before we just dive into this, so what are we actually looking at here?
Okay, so you see the tool as bare bones as it can be. I started with this setup to show you this setup because the way we do stuff in our tool is a bit unique, and that is one of the keys of our working fast. And so what we have is basically our own windowing system, and you can add we call them workbenches, like we have an empty workbench here. And what you have here is a bunch of windows that you can just add and set up as you want. So you have, I will go through all the different parts of the tool itself, the texture generator, the material stuff, all the modeling, scene, animation and timeline stuff. But
awesome.
All of this has a bunch of windows associated to it, and what you can do is just create a layout for yourself and set it up any way you want. So you can have the final visible layout, the final preview of the demo next to the texture generator, and just tweak stuff in the texture generator and instantly see the end result. And
that's awesome. Through the entire chain as well?
Yeah.
That's really sick.
It's all completely modular, and that's the whole idea that what Chaos said back in like 15 years ago about reducing turnaround times, that really stuck with me, and that's the whole idea. So I just wanted to show you this part so I can like add a bunch of stuff here, add like a preset layouts or whatever. I have some. Sorry. Yep.
I said, oh, that's cool.
What I have here is I'm going to restart the tool. I have a preset config for this.
Okay.
Which we can go through. So
nice.
This is more of a show-offy setup.
So actually, before you get much farther, so is this the third or fourth big sort of intro tool that you've done with Conspiracy?
With Conspiracy or without? Because
either way, I'm actually pretty curious.
So the way this started off is that in 2002 I went to Mecha Symposium 2002, okay. And I got beaten pretty badly by Farroche with my first hardware accelerated 64K intro. Cool. I came 17th out of 18 intros.
Wow.
And on the way home I was like, I can do a tool like those guys. Why couldn't I? and
Awesome.
that's when I started writing one that I wrote in Pascal.
Okay.
Then a couple of months later, I started learning C and rewrote the whole thing. So that was the second iteration. That was the one which we created Project Genesis with.
Cool.
Then we did Addict 2.
And that was Addict was that one that you
the Advanced Digital Dynamite intro creation tool.
Right.
So that was the second iteration. The third one was Addict 2. There was a fourth one, Addict 3, that we only made the actuator and design headlines with it, and an MMORPG on the side.
Right.
Basically, that was a pretty good way of seeing that you cannot really make a demo tool into a game engine.
Right.
Then after that, I started rewriting everything, which fell apart completely. So that was iteration number 5, which never released anything, and this is the 6th one. Yeah.
Wow.
It's 16 years of work.
Yeah, so you guys have been around the block.
Yeah.
It's actually funny, too, because I remember around, must have been 2005 or 6. Must have been 6, because by then you guys had already released Addict 2. At least a public version of it.
Maybe? I don't know.
Okay, well, I remember playing around with it at that time when I was super interested in doing 64Ks back then, but of course I didn't actually end up releasing any of them that are worthwhile until a couple years ago. But anyway, I just wanted to mention that was always a big inspiration for me, so it's really cool to see where that's grown to now.
Well, I'm glad to be of service, you know.
What was that?
I'm glad to be of service after the fact.
Of course.
You know. All right. So, what would you like to know? The main question.
All right, so what are we looking at? That's a good question.
Okay, so the way I have this set up is, so basically the tool is made out of distinct parts for distinct build processes, you could say. So we have, and these parts are separated by firewalls, kind of.
Okay.
So between the parts you have static content, and this content cannot change. That is because it's the order that we pre-calculate stuff in during the load up of the intro. So first you have textures, of course, with a GPU-based texture generator. Then you can select some of those textures to be used anywhere else in the tool. Then you have 3D meshes, which are just static meshes that can be generated. Then we have scenes, which contain camera information, the layout of that's where you can drop in the meshes and all that, and that's where you do animation. Right. And then we have a timeline editor.
Cool, and that's where you sort of lay out scenes.
Yeah. That's where you cut the final image. Right. So, and yeah, then materials come into that somewhat.
Okay.
Those are the only parts of the tool, and if you look at the types of windows we have texture windows, texture generator windows, we have material editor windows, we have, I'm skipping over that one, we have model preview, model editing windows, scene editing windows, timeline editing windows, and stuff that has to do with the tool itself, because you can edit the UI in the tool itself. But that's not really important for this show.
Nice.
And we have a console.
Right. So what would making a basic texture look like? So just kind of starting at that. Okay. At these different levels.
So the texture generator is upstacking based. So it's the same as the Farbar stuff. So we have texture pages, and you have like this texture page preview. You can press space, and you have all this bunch of operators, like whatever, like a noise operator, and there you have it. So nice. This in itself doesn't show in the rest of the tool yet. You have to apply a save operator to it, and then it will just show up. Okay. One cool thing about this is that we actually have the capability to have several texture previews open at once. That's nice. So if I do like a cells here, I can just have that as a preview as well. And if I change anything, then
right, that's really cool.
So yeah, then the rest is basically it's all operator stacking. So if you want to do some weird stuff, get out of the noise, and Just make it into a pellet. Something is off. Oh yeah. So.
Okay, cool. So now you're selecting, I guess, a palette from one using the noise of the other or something.
Yeah. And that's
or coloring the first noise with a palette from the second one.
Yeah.
That's cool.
That's one single line from used as a palette.
Ah, right. So it takes like the first line of the second texture or something and colors the first one with it.
It takes what it takes. This one. Okay, I can show you the code for this. So,
Yeah, I'm kind of curious.
Basically, the way the tool works, it's all data driven. So I don't have to program these these texture filters into the tool's code and then supply a new version or whatever. It's all shader based. So I have like this default texture generator here. This layout. We have the same stuff here. And if I find like the palette. So here's the code for it, and if I like whatever return 1, then it should have changed. Actually, it didn't. Oh yeah.
Nice.
So you can just edit the code here, and it's all stored into the project itself. So we can maintain backwards compatibility by dragging our only the used stuff with us.
Yeah, that's really cool.
So yeah.
One quick thing. Someone in the chat, it was Dark Second, both him and Cheat Detector both asked, what toolkit is this tool made in? Like, and what font is that? He also asked, but also like, what is the Windows system itself written in? I'm guessing this is all custom.
Our own. Right. So the idea was that we were creating this game. We were making an MMORPG for like 12 years or so, and we needed an updated UI system for it. And I started writing the updated UI system for the new client, and we needed a test application to test the new UI. And nothing came of the second client for the game, but the application for the test became the new demo tool.
Yeah, that's cool. Also, Origami Bulldozer in the chat asked or said, please talk about the L systems from the last 64K before it's over. I believe we're not going to talk about that today.
Nope, sorry. All I can tell you is that those are more complex than L systems, and the code for those took up about 6 kilobytes from the 64, so about 10%. So
that's a lot of code.
Yes.
Cool. Okay, so here we would make a basic texture.
Yeah.
I want to put this on a model.
Yeah. Then you need a model. So the next step is you come here. Okay, I have to close your window, and hopefully nothing went awry.
Probably okay.
Everything still seems okay. Okay.
We're up to 67 viewers, by the way, so thanks everyone for watching. This is really cool.
72 now.
Nice.
Okay.
That's a new record.
Wow. I feel honored.
Yeah.
So yeah, the modeler, for Edict 3, we tried out the operator stacking stuff, and it really didn't click with Zoom. So we went back to the Edict 2 way of doing things. You have a model, and it's kind of like an operator stacker on the inside, but for the user, it just shows up like a modeling tool that you can just move around. Basically, what we do here is we have a bunch of primitives that you can place down, and you can add some filters to the primitives. So,
Citrus just said, "The fuck is Greeble?" And I want to see what happens when you put Greeble on there.
Which one? Okay, there you go. That's Greeble. It's a normal Greeble operator. What else did you expect?
Yeah, exactly.
So, and you can do it twice.
Of course.
So yeah.
I remember in the old Addict 2 tool, I always would add butterfly smoothing to everything.
Oh yeah, we don't have that now.
Oh yeah.
Well, what we have now is Catmull Clark.
Okay, cool.
So
all this mesh generation, is that happening on the CPU then?
Yes, it's all CPU based. That's something we haven't been able to move to the GPU yet. It's one of my dreams, but I really didn't have time to work on yet. So basically what you have cubes, planes, spheres, Then you have a geosphere, which is like a smoother.
The one without the poles.
Yeah, well, kinda. It does have poles, but not
better poles.
Yeah, better poles. Then you have cylinders, cones, text.
Cool.
Then you have some more interesting stuff, but we already had this in Addict, which is an arc widget and align stuff. And what you can do is combine these to create a loft. So you can basically take a path and a cross section and just make
Very cool.
some loop with it. That's how you do Torai. I think.
Okay, interesting.
I think the multiple of torus is Torai.
Yeah, it is.
Okay, so then you have these basic objects. We have some more complex ones like text input.
Oh, nice.
Conspiracy. That's also on the GPU.
And so I see this model graph is basically what you're adding these things into. Just looking at the UI on the right, you have the model primitives, and then you're combining those in the model graph. That's the idea here.
Yeah. So you have the model primitives. Those are just the stuff, the things that you can add to a scene or a model.
Right.
And then if I put down a bunch of cubes, then you have a bunch of cubes. And what you can do is, if you put a filter on one of the cubes, mesh smoothing or favorite, it just shows up as a filter. And if I add smooth grouping, then what I can do is move the filter up and down. Although in this case,
that's cool.
It won't do anything, and you can just delete that. So or maybe add a bevel.
But I guess this kind of graph is a lot more natural to a 3D artist, perhaps, than the basically equivalent operator graph, which is kind of like the inverted version of that.
Yeah, this is the flat-end operator graph, basically.
Right. Cool.
It's not as versatile, so you cannot take a bunch of things and put them together from different parts of the graph to do stuff, but it's enough for us.
Cool.
For now.
Yeah.
All right. So then
very cool.
Sorry?
I said very cool.
So those are the basic things. Then you have a bit more complicated stuff like the scatter. The scatter, what it does is takes one object and places another object all around this one object. So if I can take this, which cube was this? I can rename this the test one. So yeah, the scatter shape and the scattered object should be one of the cubes, and now you have a bunch of stuff.
Oh, that's cool. And this is the mesh being repeated on the CPU, so it's the geometry.
Yeah, and it is baked into a new object, so that's
right.
We do have some issues because one of the main reasons that I kept rewriting the tool was that we had two engines. We had one engine in the tool and one engine in the 64K intro itself, and we also always had some discrepancies between them. And the whole idea behind this iteration was to put the same engine in the tool that we have in the 64K, so we have an exact output.
Right.
But that does mean that there are some limitations. So if I were to increase the poly count of this mesh to way below 2 gigabytes, it would simply crash because we don't handle that in the 64Ks. Because why would we?
That's funny.
There we have stuff like that. The occasional crash. It really is a technical tool from this standpoint.
And it should be. I mean, this is free time working.
Of course.
But very cool.
So we can go through the filters. You have your standards like changing the UV map. Oh, tinting. Tinting is an interesting thing. We did have mapped X forms in the earlier iterations of the tools.
What was that?
Map X form. So basically, when you take a texture and you tweak the mesh with it.
Okay, yeah.
And what I did here is I separated these into two different things. So the first step is you take a texture and you tint the mesh with the texture per vertex. So if I add a tint to this one.
So it's like your basic displacement map kind of thing.
It's not yet. It doesn't do anything. The only thing it does is it adds an internal color value to the vertices,
okay.
and then you have other filters that use this information. So, for example, the scatter can use it to see where you can place more stuff and where you should place less stuff, like a probability value. Or
That's interesting.
Or for the mapX form, it's the obvious.
Yeah.
Which is just to make it deform. Yeah, I think we would need some better texture for this.
Or a different contrast.
Yeah, what we can do here is come here.
Mm-hmm.
You can now see the whole point of this.
Yeah, this is great.
Yeah, it's a bit more abstract now, but I think yeah, I mean, oh yeah, the problem is that we don't have a proper UV map here, so what is going to happen is I'm going to move this up, and
maybe before the tint, or is that?
Yeah. There we go. So
there we go.
That's what we wanted to see.
Yeah.
But you see how it works.
This is what 64Ks looked like back in the day.
Oh yeah, chaos theory is basically this.
Nice. That's awesome.
All right. So then you have the mapX form, the mesh smooth. There's the replicate one, which is pretty basic. It just takes another transformation matrix and like replicates it a couple of times. So you can do this kind of things with it.
Cool. It's cool that you can edit those matrices just as you would. Like you get the gizmos for those particular matrices.
Yes, yes.
Which is really
also,
helpful.
oh yeah, this is a new version of the tool that I didn't set up. So we now have a model matrix window. This was done like last week, and yeah, what you have here is you can actually edit the values manually as well, and they're converted into SRT if you're like an artist guy who wants to use those numbers.
Yeah.
So yeah.
To answer a couple questions in the chat, this is one program. This is the Apex intro tool. Is that what it's called?
Yes.
Yeah. This is all one tool to make 64Ks. In particular, this is what Conspiracy uses internally. Yes. So everything you're seeing is all in this one tool, which is really cool.
Yeah. We use a separate tool for audio. We can only load the music into here, and Garga uses Buzz to just make the music. So that's separate.
Our synth is totally modeled on that same workflow as well, by the way. But instead of Buzz modules, it ends up being VST plugins for something like Ableton Live.
Yeah.
So a lot of inspiration taken from you guys over the years.
Thank you.
Oh, and by the way, I'm super happy you guys still host that old synth article that Kebby wrote.
Of course.
That article series on your website, because that's a great place to find that.
Is it gone?
And that was also really, really helpful when I got into synths.
Is it gone from Kebby's site or what?
I don't know.
Okay.
I haven't looked. I always just went to your guys' site to find it. So.
Okay. Yeah, we should put out some new articles on there. But yeah.
Well, the ones that are there are already pretty helpful still.
All right. So that was replicate. Then we have smooth groups, which is just how to calculate the normal vector. You have your standard bevel, which oh yeah, we do have crashes sometimes.
Who doesn't?
Yep. So and of course it only happens live. So what you have is a bevel, which is just a bevel.
And of course this works on arbitrary meshes.
Yeah, but not that well.
With varying degrees of success.
Yes, of course. So I can do it like on I can try it on a text and see what happens. Hey, and weird shit will happen. Yeah.
Well, as long as it's what you see is what you get, weird shit.
Of course it is. Yeah,
and
it also has some breaks in it, so now it's completely broken.
Yeah. But it might be useful for something else.
Yeah, I mean, that's what Zoom is about, doing some weird shit with this stuff.
Cool.
Then we have a new thing which is just a normal deform. It's basically what the mapx form does, only it takes into account the direction of the normal vector, which can lead to some better height fields, because you don't only have a height field, you can just like make the stuff go to the side as well.
Cool.
We now have CSG. We never used that before ever, but
Oh yeah.
if you don't know what that is, it's when you do this stuff, this kind of stuff. Just let me. Yeah, we need to hide this. And what you do is subtract it, and you have like one
Very
model
cool.
that's weird. It's very buggy, and it messes up the topology like hell. So
Citrus asked if you could explain a bit more on how you do the CSG, or at least point to some kind of technique. I guess it's not that straightforward.
It's BSP3 based, so it's the cheapest, dirtiest, worst kind of CSG you can do.
Okay.
It's the same stuff we did back in Addict 1 that we never used.
Minimum viable CSG.
Yeah, basically, yeah.
Tropical Trevor asks, does the normal deform use the entire tangent matrix and take RGB as offset in that space?
No. It just takes the normal vector and pushes the vertex out in that direction.
Okay.
It's pretty bare bones.
Cool.
I think the only place we use that for now is in the last intro for the asteroids.
Right.
So, alright, then you have the Greeble. I've already shown that. And these are just things that don't work, and there are placeholder buttons. So yeah, that's the mesh editor. Any questions?
Heiko Barons asks, how do you version... let's see, how do you... the sentence is a bit weird here. How do you version of Apex versus engine used for the production? Oh yeah, so he's probably asking like how do you keep those things in or out of sync in terms of the different engines. But I guess now it's the same engine you mentioned earlier?
Yeah, it's the same engine. The thing is that the way this works is we have an exporter. So the internal file format for the 64K intros itself is like a media format. And the intro itself is only a player. So that has been that for a long while.
Yeah.
That's one of the key ways we are making 64Ks, because then you can separate code from data, and it just compresses a lot better.
Right.
If you look at the source code for Chaos Theory, which we released a while back, it already used the same concept. You have a player, and then Chaos Theory, the intro is like it's a header file with a bunch of numbers. And that's that. So we still do that, and what the tool does is that upon export it takes the current engine build and it exports for that.
Right.
And it also of course it exports a bunch of headers of what to include and what not build into the engine.
Very cool. I did notice, because you mentioned it compresses really well, and I can definitely vouch for that. I gathered a bunch of uncompressed intros when working on the Packer stuff I've been doing, and your guys's are by far the biggest, uncompressed.
Yeah, but that's not because of the visuals. Our sound format is very big.
Okay, yeah. I mean, it compresses really well, so it's the right thing to do, but it's just really funny.
I never looked into that, though. So,
yeah.
So the visual format is my part. Gorgoy did the audio format. And what is another trick to make these things smaller? So what you can do in these file formats is like store data as they are needed. So in one stream, like you need a bunch of textures, then to store the textures, then you store like for each model you store the model type, then the parameters, and then the model type again, the parameters and stuff like that. Yeah. What we did to help with this is we separated similar data into separate streams. Right. So, for example, we have, I think, a stream for spline keys. We have a stream for model types. We have a stream for text. Yeah. And that helps the compression a whole bunch.
Yeah, it helps the adaptive models kind of adjust as it goes through different types of data.
Yeah.
Neon I2 asks, how do you version an operator in the tool? Say that a new parameter gets added or removed.
So the way that works is everything in the tool has a unique ID, like a global unique ID. If I create like a new model or a new texture filter or whatever, then it gets this ID. And when
right, so you're basically forking them then.
Kinda. What happens is that when you create, so if I were to like create a new texture filter here,
yeah,
this one, which just says, I think, new filter now, new filter, which is the default texture filter. It does nothing. It now has a new unique ID. If I export the project, then this filter will be included included into the project. And the way the tool works is that when you open the tool or load a project, then it wipes everything out of the memory and loads your project, and afterwards loads a default set of things that are just supplied with the tool. So these filters that you see, they're in an XML file next to the tool that are loaded after you have loaded your project. And the key idea is that if the project already has some of the GUIDs that would be loaded from the external source, then those aren't overwritten. So the stuff that you use in the project travels with the project. And only the stuff that you use in the project is exported. So it's pretty simple.
Nice.
All right. Next question.
I think we're basically out of questions from what I can tell. Okay, actually, Citrusley asks, is there March geometry like transforming distance fields into geometry?
Nope.
Nope. All polygons.
Yep. Well, that would be polygons as well, but no. These things were like something from 2 years ago, an idea, but I never really got fit anywhere with them.
Okay.
So I looked into doing marching cubes for like 2 hours, and then just went to watch the movie and forgot all about
it. Fair enough. Heiko Barons asks, does that mean the latest version of the tool is capable of loading and editing productions from years back?
Yep.
Very cool.
There were some breaking changes, like when we switched to a linear pipeline. So I'm going to show you a bunch of intros later, and you will notice that the off-screen colonies one has one event at the whole bottom of the event chain that is just a gamma correction, because that was still done in the non-linear pipeline.
Right.
But yeah, it can, and it works.
So we have this awesome model.
Yeah, the weird model. We don't have a material on it though. So what you see here is like the just the test material. If I were to export this, then the model wouldn't even be exported, because it's just not used. So we have a bunch of materials. The materials work just like the texture filters. You can write new ones in the tool.
Yeah.
And I'm not sure that I'm going to go very deeply into this. Basically, we copied the DirectX FX system.
Okay,
and for the layout and the terminology and everything like that. And we implemented something like that. So if you want to know how we do materials, just look that up.
Very cool.
The whole point of this is, though, that this is our material editor. We have a bunch of shaders here. Like FXAA, you have a bunch of passes here. You know, the standard FXAA shader. You have the inputs and outputs here. And this is the part that optimally the designer doesn't see. So the user doesn't see this. This is the coder part of the tool.
Sure.
What I can put here are the inputs and outputs, well, mostly inputs of the shaders and materials that then later generate a UI for it, which shows up here. So I've was to use this. You can see there's some specular shading going on here. And this UI is generated based on the material itself. So nothing is hard-coded. I can just add a new parameter, send the material to Zoom, Zoom loads it up, and it will just show up for him.
That's really cool.
No work, no hassle. we can. Oh yeah, we don't have the texture now. Yep. Just take that weird texture.
Yeah, this would be fun.
And now
nice. Beautiful.
So now we have a nice model. Nice weird model. With some more. Yeah. So, but this is a static model. So there is one other thing that we had from way before Conspiracy was even born, which is the clone stuff. If you create a clone of something, that doesn't get rendered into it's not a new mesh actually.
Okay.
It's the same mesh rendered again. Okay. So basically it's an instance of this. If I were to change anything on this, like whatever, then it's something I can just change the texture, so it changes with it.
Right.
This is something that's very nice to do some bigger things or repetitive content, because what you can do is then just take these two, you can clone a clone. So
right. That's cool.
You can just do that and then do that again. And they can be moved separately. So if I were to move this, then...
Ah, really cool.
Or that wasn't that a good... Yeah, that. So
that's
you can
nice.
do that. But once it leaves the modeler, it's baked. Well, not really baked, but from the viewpoint of the artist, this is a static model.
Yeah.
It cannot change, except for animated material parameters. But that's you know, we have some material parameters that can be linked to from the keyframer. But that's it. If you put if you link that into the vertex shader and do some fancy stuff with it, change the UV map or change the actual vertex values, then it will be animatable. But for all intents and purposes, they are fixed static meshes.
Cool.
So yeah, then you go into the keyframer, which is where we do animation and scene setup.
Nice.
Basically, if you were to thinking in movie terms, then this is where you get the props, and this is where you shout camera action.
Nice.
So you can just add the model. You can see that it's black because we don't even have any lights. So the modeler has some preset lights here. You can just add the light now, and then we have some lighting.
Nice.
And what you can do, our camera system is set up in a way that you have to place the camera separately and the camera target separately.
Okay.
So we have standard forward kinematic stuff. So if I were to like link the light to the camera and make it in a point light, then now the camera is the thing that lights up everything.
Nice.
And what you can do is just, we have a standard dummy object which does nothing, it's just a node in the hierarchy, and that's what we usually use to use as a camera target.
That makes sense.
So now it's connected, and if we go into here and select the camera view, then you can just... Yeah, we stole this grid from the Mercury tool.
Of course.
Not ashamed to admit it.
Yeah, shouldn't be.
So now we have a camera, and this is exactly what is going to show up on the timeline. Not much to it. We have a spline editor, which is we do every animation is in the 0 to 1 time frame. So you don't set the length of anything here. You just set like an animation that this should move from here to here, and then it will just do the movement.
And the length is going to be determined later when this is put on the timeline?
Yes, exactly. One thing that we have here that is a bit unique is, I'm just going to create like a new model sphere. This will do. So we have now this weird texture here.
Yep.
Let's make a new scene, add the new model. I'm not going to place anything else here.
Okay.
What I'm going to do here is just create an animation for whatever I can. We of course have auto key features, so what I can do is
I like that it becomes really bright red to make sure that you know it's on.
Yeah.
I'm sure there's been several mistakes that led to that.
That was something we learned when doing the game.
Right.
So we have this in Ep.043. So we have this animation here. What you can do here is go into this scene and add the new scene as something that's called a subscene. That's just an object now.
Yeah.
And this is a very specific two splines. The subscene clip, which selects the clip, because for each okay, I will get into this in a bit.
Yeah.
And the subscene time, which is basically where it should be in the animation.
In its own timeline.
So what you can do is just do weird stuff like that. Do like a forward and back movement.
Yeah, that's cool.
And then you can place several of these. So if you have like a complex object hierarchy with like a guy walking, you can just place 10 guys walking in another scene.
That's cool.
We also had this for a very long time.
And is that subscene time? That's the subscene time for that specific subscene object.
Yes.
So you could do this a different one for different subscenes.
Yes. So you can see, and it also, of course, works in the 0 to 1 time frame. It just.
And what is that subscene clip parameter?
Okay, so the subscene clip is if you see here, every scene of ours has several clips. So if I were to create a new clip for this one, then it's devoid of all animation, and you can just do another animation. So if we go back to the example of the guy walking, then you can do the guy running, the guy sitting down, the guy whatever, and the subscene clip just selects that.
That's cool.
And that's a spline as well, so you can just switch between them. But of course, it's an integer spline, so you cannot interpolate between the animations. That's just no need for that.
Yeah. So then I guess when you put this on the timeline later, and I guess we'll see this later as well, you select the scene and then which clip.
Yes. And which camera.
Okay, of course, yeah.
Yeah. So yeah, this is it. And if we had some animatable parameters. I'm not sure if there's a material here for that. I will just let's see. Nope, no animated parameter. I will show that later when we show the actual intros.
Okay.
But all the material parameters that can be animated show up here as splines.
Cool.
A new thing we did, which Zoom very much likes, is we added the ability to add some basic waveforms to these splines. So like a post-processing step. So we can add noise.
That's cool.
And you can just set the frequency here to whatever. Like 100.
So here's your camera shake.
Yeah, exactly. That's what it was used for mostly.
Yeah.
And you can make it multiplicative if you want to. So if I want to do like this, it will just.
That's cool.
Or you can just make it additive and then it moves it. So yeah.
Oh, that's really cool.
Okay. So that's that. And one other thing we have here is, of course, the particle engine, which is pretty bare bones. You can just add an. This might take a while to set up though. So you add an emitter here, and you have to. Then the particle system also takes a material. So you then have the material set up here. So this is where you select the material. And you also have to set the texture, and there you have a basic particle system.
Nice.
And yeah, and of course this material can be edited as well. It's just like the others. So yeah, we have a basic scene that looks a bit weird, but it works.
Perfect.
And now we want to make a demo.
Yes.
what you do?
You made it this far.
Yeah, you go to the timeline editor.
Mhm.
And timeline editor. This is basically the very same thing that we had back in Addict 1. That was a very nice concept that just worked. And it's from what I've seen, it's quite unique. I haven't seen anything resembling it quite in the commercial world either.
Okay.
And all the other tools that I see are not really that intuitive for me, so I just don't understand. But
Sure.
so the idea behind this originally was that if you sit down to write a demo,
Yeah.
you hard code the timeline, what you will end up is like you have you want to make like one scene, and I will just select the stuff here. So you want to make one scene. That's okay. You say if the time value is greater than the scene start and is smaller than the scene end, then render.
Yeah.
Then you want to make another scene. You put it into another if. But the second you have like something like doing whatever radial blur over only part of this, then you have to do an if for this part.
Yeah.
Then you have to do an if for this part, and then
Right.
this part, and it gets really annoying real quickly.
Mhm.
And this timeline was a solution for that. So basically,
Okay.
what happens is that you have one single time frame where you are right now. It's actually an integer frame, so we can render the same image exactly.
Yeah.
We don't do floating stuff. We have an internal frame rate, which is usually set to 120 hertz.
Okay.
And then the events are evaluated from top to bottom, but only those that intersect.
Right.
And that's all to it. And
Okay, cool.
it's very visual, it's very easy to do, and very easy to edit.
Nice.
And because the minimal engine, the way we call it, the intro engine, the engine itself is very stupid. You have to place an end demo event that just quits the executable. Because
Nice.
these events can do anything. They can do Bitcoin mining for all I care.
Nice.
So this timeline, if I were to start writing a demo tool or from scratch without any knowledge of this crap, the very first thing I would do is a timeline like this because it makes editing so much easier.
Yeah, I can imagine.
So yeah, that's it.
Very cool. So we've made it all the way to a demo here.
Yeah, we have a demo here. We can
I
watch
mean, it's the same scene twice, but
Yeah, we have, and we don't have particles, and there's a reason for that, because particle calculation is an event of itself. So what you do here is there's a reason for that, and I will get into that. Particle calculation. You select the scene, and okay, a bit of a question here. Who can tell me why you need to select the camera as well?
Because you have different camera objects in the different scenes. So here you want to have the same scene twice, but maybe with a different camera
why
angle.
do you have to select it for the particle calculation?
Oh, yeah, I'm not sure. Unless it's to give the view matrix for the particles.
It's for the depth sorting.
Ah, right, of course.
So yeah. And the reason for this is that our particles are pretty stupid.
Okay.
And if you start the intro here, then you see the particles system will start from scratch. It just resets.
Yeah.
And so what we do is we do the pre-calculation during the demo. So you have the particle calculation that starts before it should show up in the scene, before you're actually showing the scene, and then it just works nicely. Zoom figures out a good delay before it should start, and it just works.
Right. So I guess for example, the asteroids in the most recent one might have been something like that.
No, there was no need for that because they were just scattered around.
Okay.
What you can do now, that's another new feature that we did, just for that intro was that I can take this particle system, and if I can find a UI for it, it can emit an object. And
That's
now
cool.
it emits an
Nice.
object. So yeah.
Quick question that I have. So when you're doing the particle calculation, do you do that like with the fixed internal frame rate?
Yes.
And so then it makes a lot of sense, I guess, in the timeline to have integer frame rates or
Yes.
integer frame positions, because then when you do something like you just showed, where you want to pre-calculate the particles for a certain amount of time, they will always have ran for the exact amount of
Yes.
frames
Yes.
before the next scene is actually rendered. So that's actually pretty cool.
In the intro itself, yes. If you have seen the teardown video for the new intro,
Yeah.
if you look at the very first scene where it dissects the asteroid field scene, it will skip a bit. The asteroids are a bit in a different position. That is because it was done from the tool, and by the time Zoom did some other stuff, the particles just moved away.
Oh, I see.
So that's behind the scenes look.
Yeah, that's funny.
On the behind the scenes video.
Cool.
Okay. Yeah, this Zoom asked a lot for this, and I'm just to be able to select a specific resolution here because reasons.
Sure.
And since I'm doing this from my laptop, if I'm going to start showing intros, it's a good thing to have. So we are going to go down to 720p for the previews.
Okay. Great.
Okay. Any questions?
So there were several questions. I'm just going to pick out a few here. One of them, someone asked, Kaiwan Lupus, if I'm reading that right, says, how much effort, time, and planning does it take to maintain the entire tool?
Not that much anymore, because it's in a usable state. But to get it into a usable state, all the experimentation and all the crap with the UI and doing stuff and all the crashing and fixing the two engine problem and all that, well, it took 15 years.
That I believe.
So, but if I were to do this in full time, it would be done faster.
Yeah, of course.
Yeah.
Trevor asked if the radial blur event has its own animation capabilities.
Oh yes.
I think he meant like to animate the parameters of it.
So the way this works is that the radial blur is not actually a radial blur. This is something that I call that's handled internally by the tool. It's called a shader toy event.
Okay.
Because what happens is you can do three types of materials. One for normal meshes, one for particles, and one for post-processing. And so the post-processing materials can have animatable parameters, splines as well. And they just show up as separate events, separate instances of the shader toy event. So this one, if you can see here, all the events have their own spline editor stuff.
Right.
They all have a global timing parameters. So if I want to like reverse the animation of something, I can just do it from here.
Nice.
And that's very well convenient.
Yeah.
Also, if you want to loop animations, then you can just loop it.
Very cool.
And if I were to expose some parameters of the radial blur stuff material to be animatable, then yes, it would show up here as a new parameter that you can animate.
Really cool.
Okay. Next question.
Yeah, I think we can. Actually move on after this. Oh wait, actually, so is it Stism Maker asked, does this still happen to be based on any existing ones or just own tuition experience with it? I guess that's a mix.
I never actually looked into anything really. I just it came to be from experience off the top of my head stuff. And yes, then we stole a bunch of ideas from Farbroush and from here and there. But
of course.
But basically, the whole concept has distilled down into this after 15 years.
Cool. Neil, I asked, can you make a composite operator? I'm not entirely sure what he means, but I guess meaning taking a bunch of these other events and then making a new event out of that is maybe what he means?
No, not yet. Zoom asked for that for a while. We have similar capabilities in the tool for the texture generator, but the minimal engine doesn't support it yet. So you can like do a subroutine operator that you stick onto an operator tree, and you can expose a bunch of parameters from the tree itself. And then it just shows up as a new operator, and it will have those parameters that you want. But it's not something that we used yet. That was one of the first things that I did for this too, and it hasn't been used before. So as for compositing these events, no. If you mean if I can like do 2 renders of 2 different scenes and do something like a crossfade, then yes. What we have is, there are several ways of doing that, but the most trivial one is just take the copy to render target thing, which takes this result and it copies it to input should be the back buffer, the out render target should be whatever the temporary one, and now you can use the temp1 texture anywhere you want, even in the material editor, whatever.
Nice.
That's something again that we haven't really used, but yeah, you can do that.
Very, very cool. I think that's all the questions I'm seeing and I want to ask.
All right.
So why don't we go over some intros?
All right. Well,
unless of course you have more that you want to share with the tool.
No, this is it basically.
Very cool.
So, all right. I am going to sometimes restart the tool because emptying a project from memory is not one of my strong suits. So there may be crashes, but let's just go in chronological order.
Cool.
And yes, the XML loader is dead slow, and we crashed, of course.
at least you thought it might happen this time.
No, I knew it would happen.
All right. It was planned.
I was pretty sure that it would crash. So yeah, this is where questions will be more oriented towards Zoom.
System Maker pointed out _final_final. So it's definitely an artist that's been working with us.
Yes, exactly. So this is still in the old nonlinear framework. So and this does have some buggy things in it. This was the very first release we did this with demo tool.
Yeah, this was NVScene 2014, correct?
Yes. The reason why I'm scrubbing over this is everything is only loaded on a need to load basis, and if you want to like have smooth, and the tool is single threaded, so if you start pre-calcing stuff, then it will like make things slower. So I usually scrub through the whole timeline just so we are able to work without interruptions.
Sure, warm it up.
So this is a bit lighter than the actual intro, and that's because of the gamma stuff.
Yeah. One quick question before we move on. CBDT asks, he says the tool is obviously pretty fixed in how it's operated. What's the reasoning behind going that way and not, say, a massive node graph?
It was easier for Zoom. But
the thing is
that's not really true, because parts of it are a node graph, just in the operator stacking way. So everything is done in a way that fits our workflow.
Yeah, a big partition node graph that favors certain workflows for certain parts of the graph, I guess.
There is a dev blog that I did when I started doing the previous iteration of this that crashed and burned. And I did try doing a node graph thingy, and it was too messy.
Yeah.
I didn't like it.
Sure. Cool.
So yeah, but there's nothing keeping us from doing that. It's just not something that we like.
Yeah.
Okay, so let's get on with the questions for the intros. I'm guessing you want to see some newer ones. I can demonstrate something here that will come in handy in the next previews of the intros. So as the timeline moves from the top to the bottom events, we have a debug thing here that I can stop it anywhere. So
that's really cool.
if you see this horizontal line, it's very handy to show the actual steps of doing the frame. So
Oh, this is awesome.
we start with this texture, and then I have no idea what Zoom is doing here, honestly. Some weird stuff. So this is a 3D scene that does like these stripes. Then it's rendered again. So then you have the FXAA. Then some design. This is so the green ones are 3D scenes, and
Okay.
I can go like come here. Okay, so this is the scene.
So that little menu option, this basically opened the default texture generator, but focused on that scene there. Or
Yes, yes.
something.
That's something I wrote specifically for this. So for this stuff that we don't have to do all the searching around, and yeah, it's buggy still. So what I can do is like open it in the modeler. That should be or this the keyframer. That should be easier. So this is one scene. And
very cool.
And you can take this and go to that model. So and there you have this one model that is just 3 planes.
Yeah.
And that's that. Yeah.
Really cool to see this, how this is kind of broken down.
Yeah. And then you can go into like, where's the banana? Never know where the banana is. Okay. So
it's super banana.
Super banana. You go into the keyframer and you can just select the banana. Yeah, you can see the weird naming conventions that Zoom has sometimes here.
That's how it's supposed to be in these kind of projects.
So yeah, and we actually have a bunch of stuff that hasn't been used. You can see that the end of the banana is actually not really there. It's just
nice.
hidden cleverly. And so you can see here the way the filters are set up. So you have that tint, and another tint, and the MapX form, mesh smooth, and then smooth grouping, and that's all there is to it.
And I guess it looks like this started with a couple arcs to do the different parts of the banana.
Oh yeah, it started with loft, yes.
Cool.
I can disable these filters so you can see the steps. So the smooth grouping does the. I'm not sure how this comes over the stream, but
yeah, I can see a big difference here at least.
So this is flat shaded.
Zoom points out that the naming conventions get weirder as the deadline approaches, which is also very natural.
Of course, and as the number of not slept hours increases.
Yeah.
So this mesh smooth actually doesn't do anything. Oh, it's linear. I guess it's for the benefit of the smoothing group there.
Okay.
Then, without that MapX form, this is your banana.
Oh, so it kind of pinches the top of that then with a map.
Yeah.
That's funny.
Then, without this MapX form, it's the other end.
I guess that's what that red thing was with the tint.
Yes. And
pinching the ends.
And this is just a loft. So if you see here, it's like a part of the. It's a partial torus.
Yeah, this is a cool breakdown of how to make a banana in this kind of tool.
Yeah, I mean, I would never have guessed how to do it. It's all.
Yeah, same. That's like this is genuinely interesting. I sound sarcastic, but I'm totally not.
Most of the time when Zoom does an intro, I just go, "How the hell did you do that?"
Awesome.
Now I have to look it up. Okay. What intro would you like to see? Broken down.
So I'm particularly interested in some of the scenes in off-screen colonies.
All right. Another crash coming up, just saying.
Yeah. That leads into a different question. Neon, I asked, what kind of memory management do you use?
It didn't crash. None.
None, right.
We don't have any smart pointers or the like, so it's just all brute force. And
what is this green bar, by the way, that's filling up?
It's loading it's pre-calculating the music. It's rendering a wave file from it.
Cool.
For the other intro, it wasn't loaded, so it wasn't referenced in the project file. That's why you didn't see it. And yeah, we should wait for that because I'm thinking that might kill the stream a bit. I just, flood everything. That is being done in a separate thread though, because,
Yeah.
because it's Gargoyle Tech and it's more advanced.
So one of the things that I can definitely see you guys got a lot of mileage from rendering wise in this one is screen space reflections.
Yes. So.
And I'm wondering if there's any kind of
without.
Oh, cool.
With,
this I want to see.
Without. Yeah. It's buggy as hell, but it worked.
Yeah, it's one of those things. Again, if it's weird stuff, but it's what you see is what you get. Weird stuff.
Yeah, exactly.
And it's the right stuff.
And then it's all up to Zoom and his patience to bury the tool. So here you can see that the particle calculation actually starts in this scene for this scene.
Right, so you actually have them going all the way down before.
Yes, yeah. This one as well for the particles that go up.
Right, cool.
And yeah, and when you're sitting here in the tool itself, then it just animates.
Yeah.
Because it doesn't really matter. When you press space and start playback, then, it just works.
Really cool.
So, what would you like to see?
I would kind of like just to see, like I really like when you go through that, the vertical line through the timeline, like see kind of a breakdown of a lot of these scenes, because it's like I'm particularly interested in a lot of the post pipeline and stuff as well. But I mean, anything you're willing to share. I don't really have any specific questions about the intro. I just really like to see how a lot of this stuff is broken down.
I guess this is the most, one of the most beautiful scenes here. So let's go with this.
I think that's my favorite scene.
Yeah, mine as well. And I can tell you that is why Fairlight got the headline here, because this was the most flashy. So
yeah.
It's like a small bite at them.
Okay. So I would imagine a lot of these. Yeah, let's go through some of the layers, and then I have some questions about some of the geometry.
Okay. So the way this works is you have this background, and this is the scene. It is a particle, system in there. It just moves, so there's no gravity or anything in there.
Right.
You have a bunch of the same model at a bunch of resolutions. Then you have the screen space reflections, of course. Then the depth of field.
Yeah.
Then there's a glow effect that's tinted a bit, I guess.
Okay, right.
So yeah, you can tint it here.
That's cool.
That's just another material. Then you have the lens flare effect, which is something that Zoom specifically requested for this, and I fought him tooth and nail, but I gave in, and it wasn't overused, so...
Yeah, that's I guess the fear there.
Yes.
That looks great.
And then there's, again, this palette stuff. And this is where we go into, so it's very light because of the missing D-gamma effect. So if I will just do some stuff here. Move everything down a bit. So I can bring this D-gamma up. So you can see how it actually looked when we were doing it. So this is what you have pre global post effects. So we have some chromatic aberration in there, which is, why not? It doesn't really show. And then there's the film grain effect. I'm not sure if that comes across on the screen. On this part, it's very visible on my screen. So
yeah, I'm seeing it a lot on Skype actually. So
without, this is it without, and it's with.
Yeah.
And that actually gives a lot to the feel of the intro. It's really weird. It's very small, but it does that. Then, and after that, you have the FXA. So about when we apply anti-aliasing and where it's not really discussed. It gets put into where it works the most.
Yeah, of course.
By Zoom, so there's no a method to this madness.
Yeah. Very cool. Really cool to see the layers of this come together. A couple questions I already have about the geometry. So I guess these spiky things.
Yeah.
It looks like a lot of repetitive cubes in geometry.
Yes, let's go find those. Yeah.
I'm also curious on how the animated floor works. I really like how that looks in the wireframe.
Oh yeah, it's just a bunch of weird shit. So cool. Yes, you have a cube. which is
Somewhere.
Yeah, basically it's all done with one cube. It looks like there's another cube. Wow.
Yeah, so definitely some repetitive stuff here.
Okay, so basically I think this cube, I'm not sure if you can see it somewhere. It's hidden, I think. Yeah, it's a hidden object, so I will just put some... Okay, this is the cube that Zoom started working with. It was hidden because it's like a temporary object. And you can see that the resolution has been upped a bit with mesh smoothing.
Right.
And if we hide it, and then there you have this cube, and this is hidden as well, which is just like this simple. It's just a normal cube that's a bit elongated and rotated. Yeah, and then you have a scatter where Zoom scattered the second cube over the first one.
I see.
Which just resulted in this. Wow, nice. Which resulted in this messy shape, and then I think there were a bunch of other scatters. So yeah, this is the first scatter. You can see the white outlines.
Yeah.
And then there's another scatter.
Right.
Then he did a cylinder for some reason, and there was he scattered a bunch of cylinders across. That doesn't really show in the intro. Wow. Okay.
Oh yeah.
Then there's a cube which replicates, which is, I'm guessing, these things, which was also scattered around.
Yeah, that's definitely what that is.
So it's just a bunch of cubes and cylinders.
Yeah.
Basically.
It looks really cool though. It's one of those things where it's, I guess, just a bunch of crap thrown together, but then when it's composed properly in the frame, it looks really nice.
Yeah.
Really
this is
like that stuff.
where the artist's eye comes in. So he'll just sit down and mess around with it until it looks good. And that's the whole idea, that if I were to go into this overview window here, and let me just find these scenes again. This is so cramped because this layout was done for a 4K screen, and we're obviously not on a 4K screen.
Yeah.
So yeah, the overview, and you get that, and open it here. So this is where this type of working is very nice, because you can do this.
Yeah, that's really, really cool.
And the whole thing just works.
That's awesome.
Right. Questions?
I had another question about the floor. How's that being animated?
I don't think it's animated.
Okay, then it's fooled me all this time.
Oh no, it's just moving.
Haha, nice.
That's it.
Awesome.
And the camera.
I love this smoke and mirror shit.
Yeah.
That's my favorite. Cool.
So yeah.
The reflections do a lot for that, I'm sure.
Yeah, and it's semi-flat shade, so some weird smoothing group stuff is going on here, and that's what makes it look that way.
That's brilliant.
Oh yeah, this is still bugs.
By the way, if anyone watching has any specific questions about any of these scenes, please fire away.
Go ahead.
I don't know if I meant to be, if I pointed that out. Like, I really want a lot of questions here, so.
Yeah, we have.
This is a great opportunity to see how this stuff is broken down.
Yeah, thing is that from here on now, when someone comes up to me at the demo party and my voice is already going, I would just send them a link to this. So ask now.
Totally.
Because Gargoyle can attest to the fact that people come up to me all the time at revision, for example, and I spend about 30% of my demo party showing the tool.
That's got to be fun, though.
It is. It's cool. It's nice to have a reference.
Yeah, for sure. So let's look at some of the other scenes in the meantime.
All right. Or another intro, maybe.
I think there was one in here, because there was a couple in here I want to see. So this one in particular, I actually wondered that pink sphere there.
Yeah.
Is there also a light there, or is that just?
There may be. I don't know.
Okay, yeah, it looks like there is.
We can just check it out. Let me just go here. It's easier here.
Yeah.
Thing is that This double clicking thing is a bit bugged because it doesn't release the mouse cursor.
Oh
See?
yeah,
So it just moves it.
because this was actually one of my favorite scenes as well. Just the way it was
like
composed just looks really great.
It's just see it here. Oh yeah, this looks so weird here. So you have this big
actually a sphere.
with this thing.
Awesome.
And yeah, there is no light there, and there might be a light there. Let's see.
Cool.
It's just okay. This is too crammed up.
Neon, I asked, can you import from Shader Toy?
No.
And he also asked, do you have a time profiler?
No. And
Cool.
so all of this is in DirectX, so we use HLSL, and I would not want to write a cross compiler just to import from Shader Toy. Why would you want to import from Shader Toy? You can. There are a bunch of good ideas there, but it's like if you do a shader core for 4K, Shader Toy 4K, it's like doing an asset flip Unity game.
Yeah, I know what you mean. Zoom also points out that this was the first scene that was made for OC as a proof of concept, which is really interesting.
Yes, yes. Yes, there's a light there.
Right. So that's where a lot of that shading actually comes from.
Yeah.
And then, of course, the screen space reflections fill in the rest.
Yes, so that's also a nice fake.
Yeah. Really cool. I really like the way that, in particular, I think your group does this the best in terms of just really creative ways to build scenes.
Yeah, doing much with nothing. Yes.
I wouldn't say nothing, but you know what I mean. Like it's, or I know what you mean rather. I think the Darkness Lay Your Eyes Upon Me was probably the best example of that I recall. But of course, there's examples of that in all of your guys' intros.
Darkness actually has some pretty decent modeling, actually. I can show you that later.
Yeah.
Okay, next question.
So, does the maker ask what parameters does the camera have, like field of view and some other things?
Okay. That actually changed now. I did a new parameter now, just last week. So what you have is position. You know, it has the target.
Yeah.
The up vector is fixed, so that's something we need to look into because we cannot really look up because of the singularity.
Right.
And you have the field of view and the roll. And there are parameters that can be animated. So if I go here and look at this camera view, and I just move the FOV a bit, then you know it will just do this weird shit or make it roll. It's actually rolling. Zoom actually did a camera roll here. Who knew? And
you need that for the right composition.
Yeah, and then stuff that I added now is just you can move the camera off center.
Right, gotcha. Zoom pointed out he's also using a distorted geosphere for the ground plane because that's the only model type that has triangular faces, and that's what looks best for wireframes.
Yep. Yeah.
Neon Eye says, how is the file format?
Which one? There are two. We have an XML file format for the editor stuff. I used to do binary formats for everything, and I still prefer that for speed, but in terms of developing a tool that can crash a lot and maybe have some corrupted data in it, an XML file is just the best way to go because you can
nice to have human readable.
You can just edit it by hand if you need to, and in a deadline rush that is very helpful.
Oh, I bet.
You don't have to break out the hex editor.
And I guess by two file formats, the other one would be the one that actually is shipped in the intro.
Yes, that is the minimal file format that's highly optimized for speed and everything, for size and everything.
Right. Very cool. So another one of the scenes that I wanted to take a look at is the city scene. I think it's the cocoon one.
No, this one. Oh, this one.
I meant this one, Mercury one. Yeah.
Yeah.
So as you were scrubbing here earlier, I noticed these little. I would have called them cars before, perhaps ships, but they're actually from the particle system. It appears.
Yeah.
That's kind of funny.
And if you saw there, you cannot really stop the particles, but they're alpha tested and they're pretty ugly when they show up that way. You can look into this as well. So it looks like that.
Nice.
And yeah, there are your cars. The car.
That's awesome.
Yeah, just one sec. That is your car.
Great. Just classic lens flare kind of stuff.
Yep.
Really, really cool.
Yeah. I will have to fix this. Okay, next question.
So I'm not seeing anything from the. Oh, here we go. Neon, I asked, what kind of image 3D assets can you bundle with the project?
What do you mean? I'm guessing what is supported for importing.
I think that's what he means.
Well, we can load a bunch of stuff. In the texture generator, we have an image filter,
Okay.
which reaches it. Okay, so about the texture generator and editing stuff on the GPU-based texture generation globally, this thing is a realization of the article that I wrote for Zyme 14, I think.
Okay.
So if you want to take a deeper look into how we are doing texture generation, I think it's also linked on our website, so the Conspiracy website. You can find the article. And there's also some pseudocode there that explains the whole thing. And that's pretty accurate to this point, to this day. There are a bunch of things that still have to be done on the CPU, like text rendering. So if I do like a text and start typing, that's done on the CPU, and image loading as well. And we support all the formats that Windows supports, basically. So we can load JPEGs and GIF files, maybe, I don't know. The weird part is you can do, and this is a very good trick that we used for Darkness, is that you can actually load VMF files, which is the Windows meta file, which is just a GDI command list that you can render onto a GDI surface and then can scrub it onto a texture and just use that. And
that's really cool.
We actually do have anti-aliasing implemented for that, which we had to do on our own because GDI doesn't do that. But it's not that hard to do. And
that's really cool.
That way we can import vector images, which is how the people in Darkness were done.
Yeah, that's what I would have guessed.
And the custom fonts for all the 3 intros were done like that.
Interesting.
Because
the way that we end up doing that is we actually pack in the TTFs, but before we do that, we know which characters are used by the intro, so we go and zero out all the parts of the file that we know we won't touch.
Oh, we have to talk about that. That would be interesting.
Yeah, and we just render with GDI onto a texture.
Yeah, I never did any TTF stuff before, and stripping down the TTF sounds like a fun thing to do.
Yeah, at least it's a very compatible way to avoid writing a text renderer.
Well, yeah, but the text renderer is very easy because you can just use GDI and...
exactly.
What we have here is a list of always supplied fonts within Windows, and we use those.
Cool. That's nice.
Oh yeah, one other thing, this reminded me. For Ep.043, we actually stored binary shaders, compiled shaders that we stripped.
Okay.
So we stripped out the comment fields from there, and they were always Pixel Shader 2.0, so we had to use 64 instructions, and that was very convenient and very. We didn't need a shader minifier because it just worked.
That's really cool.
But for this one, because the new shader format was so bloated, we couldn't do that anymore. So we have our own shader minifier, and we do shaders, and we store the shaders.
Gotcha.
So about 20 or 30% of the visual data is shader data.
That I believe. So someone asked, FSCK Dead Beef asked, how are the lights made on the city buildings? And Jim said that might be interesting to look at.
Okay, I have no idea.
He said interesting to look at in the text gen, so I guess that's where the bulk of that is.
Let's just see the model then. Oh, these lights.
I think that's what he's talking about.
Okay, so the window lights. So, wow.
Looks like there's a bump map there too.
Oh yeah, we have normal mapping.
Right.
Okay. So you have... Wow. Yes, this looks interesting. So basically what you have is a bunch of models.
Nice.
That are just, oh yeah. So what happens here is that you have the base material that is basically your normal foam shader.
Right.
And then you have this material that is just a non-lit texture draw.
Right.
With some weird blending combination. And then if you go into the texture generator, this is the texture.
Nice. Subplasma, I guess that's to get the vertical lines there.
Subplasma, yeah. Oh no, it was done using the loop. So the X
cool.
loop is 0. So then it just, stretches it out completely.
Nice. And the text? What is the text there? Are those vertical bars? Is that what that is?
Yep, looks like that.
Oh, that's fabulous.
This is what zoom meant, I guess.
That's so cool.
That works, I guess. This is
now I want to see what some of those other ones were.
Okay, you have another text here. Is it Morse code?
There's some dashes.
Yeah, some dashes. That's just a bunch of underscores.
Ah, this is great.
Some other underscores. Wow. This is some weird shit, yeah.
This is great. Neon, I asked a couple things. First of all, do operators have presets?
Like preset values, I'm guessing?
Probably.
Yes, they do. What you can do is so if you come here and so this is the screen that I have set up for the demonstration of the texture editing, the texture filter editing. You can see the filter type here. So we have a bunch. It's basically which column this comes into.
Yeah.
We have the generators, the layer stuff, the distortion stuff, and the color stuff.
Right.
And you can set how many inputs it has. We don't have dynamic number of inputs, so if you have a combine that needs to combine 2 operators together, then you cannot have it combine 3. It has to combine 2. This is a limitation of the system that we're using. Then you have the number of passes, how many times the shader will run, and you actually get the pass info inside the shader.
Okay, cool.
And then here are the values that you can set. These are the parameters that you can set. You can set what type of value it should be.
Right.
And you have a minimum, a maximum value, and a default. And if I were to place cells 2, you will see that it says 5 and 5.
Cool. I also asked, can an operator take 3 or more inputs, or is it all 1 or 2 or 0? I suppose that'd be arbitrary. They're just not dynamic.
I don't remember. I think it definitely goes up to 3. But I think, that's passes. Yes, it goes up to 3. That's a hard limitation of the system. Yeah. But it could be, expanded if needed.
Sure. Very cool.
Next question.
I'm not seeing more questions. Maybe we want to look at another intro.
All right. I will just reboot everything.
I mean, not that I mind continuing to look at this intro either, but
Okay. Let's poll the people which intro we should look at.
Yeah, I would really like to know which intro you guys want to see.
Yeah.
We can kind of prioritize based on that. Yeah. Citrus Lee says the newest one.
Of course.
By the way, Neon, I asked a question here. Do you have conditional operators like if-else kind of things in your texture graph? I guess that wouldn't make too much sense because it's static.
Yeah, it's all completely static. So no.
FSCK Deadbeef says Chaos Theory, but that's a couple tools ago.
It's open source.
The second
Just
one, though.
download the source code, man.
Yeah.
The latest one. Let's look at the latest one. I mean, there's a teardown video for that. But you know.
Still think it'd be cool to see it in the tool. We can do a quick pass on this one and then.
Yeah. Okay. We're pre-calcing and loading music, I guess. Oh, no music
cool.
loading.
And I also saw. What did I see?
Darkness. Ask for darkness.
Yep.
Chaos Theory. Different tool. Alright, so we are starting to load up. I will just...
This opening shot, by the way, just
do the
to
scrubbing.
point out this again. I know you guys have heard this 100 times, but this opening shot was stunning.
Yeah. And
I mean, they're all really great, but especially the impression of that.
The favorite part of mine was that how it played together with the music.
Yeah, for sure.
That was just like an in-your-face opening, yeah.
Really was, especially that period of just nothing before it comes on.
Okay. My poor laptop is dying here. I'm guessing the 2 video streams don't help.
Probably not.
So
Origami Bulldozer asks, who does the direction for Conspiracy?
Zoom. When he has the time.
Yeah. I really liked that exploded Earth shot, the one in the middle there. Of course, again, all these shots are fabulous, but that one. And I remember in the breakdown, it was interesting because a lot of it looked more, the way it was composited together, it looked a lot more 2D than I would have expected.
Yep, it's hacked together.
But it reminded me of just watching like a movie breakdown where a lot of that stuff is well comped in 2D. So it was really cool to see that, especially.
Because it's not a game, so you don't have to be able to look at it from anywhere.
No.
Just a quick thing about this scene. This is actually based on an actual model of the Los Angeles skyline that we got from an artist that helped us out last minute. That we found the model on Sketchfab and contacted the guy like 10 minutes before leaving for the party. And the guy came back to us and gave us the model, and when we had a bunch of problems importing into the tool, it was a real weird thing. And then it was stripped down, and I modeled it as best as I could with cubes and like cylinders.
Trevor asked, or said he was super interested in that city interview or overview. By the way, Fibu asked for Austrian colonies, but we already went over that, so check the VOD.
Yep, look back. Which one? City?
City? Let's do the city one.
This one?
Yeah, let's break this down.
The actual breakdown. Okay.
So, or you know.
Yeah, this is how the scene looks. Yeah, it's, you wouldn't guess that. Then you have the fog, which makes everything. This is just a fog process based on the Z value. Then FXAA, depth of field, which doesn't really do much.
Not in this scene.
The glow. There's the inertial intensifier, which was done for I don't know which intro. It's basically a 2D post-process camera shake fake.
Okay.
It just, in this case, it just zooms in a bit and blurs everything.
Yeah.
There's this strobe effect, which is, I'm not sure if you can see the small flashing.
You can in the dark areas of the screen,
You know what? I will just take this, copy it over, and show you.
I suppose that kind of simulates like film flicker, but in a way that's different than grain.
Okay, that was weird, but you know. Ah, fuck! Wrong event. Yeah, I can just delete this. It doesn't really show up on this. You can see like there a small flicker.
Yeah, right.
It's a 3D scene that does nothing else. It doesn't do anything else, just flicker a bit. Then there's the vignette effect, which is really subtle.
Yeah.
Film grain again, of course. There's an animated glow, a bit of sharpening, because why not? Chromatic aberration, which you cannot actually see, and that's it.
Cool. Zoom points out the weird colors in the city scene was because of the colored fog, which puts colors in place, kind of, or so to say. This was some backwards working with the colors.
Yeah,
of course. They were fixed in post that makes them look weird on their own.
Yeah, this is how Zoom works and how he can work with this tool. So he just looks at the final result and tweaks the intermediate colors until they look good. And he doesn't check out how they look on their own, because why would he? And this is how you get this shit.
Right.
Which is just weird. You would never think about doing that. We can go into the actual models as well.
Yeah, that's Trevor in particular also asked about that. He's particularly interested in some of the textures and stuff.
Alright, so this is how this looks, because it's not just the texture on the ground, it's actual an imitated city. Sadly it doesn't show in the intro though. So what you have here, okay, so this is some blatant content reuse from Darkness.
Right, I did recognize that.
Then you have, okay, let's just go into the model itself. So yeah, not sure how much this shows. These are the cubes and all the whatnot.
System Maker says poor Los Angeles.
Yeah, well, it's a poor man's Los Angeles, yeah. Wow. There are some weird blending things going on as well. So
that's interesting.
Yeah. The city is see-through. Well, you know, whatever works.
Yeah.
So we have this, and then there we have this texture, the Windows texture. It looks like that.
So Windows.
Yeah. So this is how it looks. It's quite big, high resolution. So it's 2024 by 2014.8.
Wow.
And the way this works is you have a single rectangle. There's a fractalize applied to it. Some noise and the map distort. Wow.
Huh.
Okay. So then it's looped. It's colored for no particular reason. I'm guessing that's for the alpha. No. This colorize does nothing at all. Some optimization possibilities. Then there's a curves applied to it. So this is a color curves.
Cool.
Then comes the other side. Rectangle. It's inverted. It's colorized. I'm guessing. Yeah, this is the alpha part. It's looped.
Right. So there you get the different sort of see-through windows.
Yeah. And then it's combined, and that's what you get.
Cool.
Interesting.
That's really great.
Yeah.
And there's your windows, as it's called.
Yeah. Okay. Next question. So you guys wanted to have a look at this?
I definitely wanted to have a look at this. I know this was covered already in the breakdown video. Really cool how the layers fit together. But yeah, I really want to see this, especially in the different parts of the geometry.
If I show this, we are not going to get any nominations for the meteorics.
I think it's worth doing.
Yeah, I know.
If we win it, which we won't, we'll give it to you.
I will hold you to that.
Yeah.
Okay, so the keyframer is the key part here. Yes, this is going to be killing my laptop. Just
a delicious fan.
Oh yeah. So,
Citrus keeps asking for the foliage, but we're not going to show that in this video.
No, man, we already talked about that, Citrus. Alright, I can show it to you, but it's just going to be a bunch of trees, because everything else is hidden from the tool. Just in case. So, if you look at it from this part, yes, there are some 2D things there. I am going to show you something that is not in the teardown video, which is what makes this scene great, because I never really did a material for Zoom that does like a half Earth.
Yeah.
And I had no idea how he did this.
Yeah, I think that's really cool.
It's basically the whole Earth is rendered, and the render priorities are set up in a way that is just composited over it.
Right.
So if you look at there, you can see the dark side of the Earth.
Nice.
Like that. So the whole planet is actually there.
Cool.
And yes, this is actually some ray march stuff in there, some minor ray march for the atmosphere.
Okay, cool. I guess that's just a 2D shader there.
Well, it's a planet shader that works on a mesh, but it actually ray traces a sphere inside it.
Oh, okay, cool.
So
Zoom says, yeah, the scene only works from that angle, and then Origami Boulder says, the right one, you mean? But of course.
Of course. And yes, this is where we first used the mesh scattering particles.
Right.
And it was a lot less. Zoom has been bugging me for that for 15 years, and I managed to do it in one afternoon. So
nice.
It was a lot less of a hassle than I thought it would be.
Cool.
Okay.
Now, I don't want to spend too much time on this intro just because we had the breakdown as well.
All right.
So maybe we want to move on to a different one.
Yeah. Let's go into maybe darkness, because
that was
actually
requested.
some actually modeling took part in there, and I'm very happy about it because I'm the one who did it.
Awesome.
Darkness final. No, that's Deppy Space final.
Nice.
Okay. Again, we're loading the music as well.
Cool.
So this is going to take a while again. I really need to do some auto scrubbing for this because, why not? Okay, so now we wait until that number gets to 0. There we go. So yeah, this is the familiar scene from the previous intro.
Looks like here there's more layers of the sort of tree layers there. No, actually the like different layers of the, I want to say trees?
I think I don't know.
Hills?
Let's see. It's the same. Oh yeah, it might be the same, but there's some background textures as well.
Right.
That's how it looks. And the sun is just, a plane.
I really like this.
This was really fake. But it did really look nice. So.
It looks super nice.
And the trees have, like, they're proper trees. Kind of.
They were proper trees.
Yeah. So this is the part I'm talking about. This was actually properly modeled based on a house that we found that was in a bunch of movies.
Cool.
And what I did was I actually looked up the house on a map.
Oh, really?
And I looked up those trees are in their correct position for that house.
That's awesome.
So yeah, there's a bunch of. So what happened here is I did the model, and then Zoom did the actual texturing and setting up he did the magic part.
Very cool.
Yeah, my laptop is dying from this a bit. So sorry if the frame rate is like it's running at 10 frames a second now. All right.
Looks okay for showing this stuff for sure.
Yeah. Okay. So, questions again.
So how is this built up? If you could do a quick breakdown of this house.
Yeah, let's see if I can. That's a bunch of cubes basically and replicate.
Sure.
So this cube is like that part. A part of the house. Then there's a plane, which is I think the ground. Yes. There's a cube. That's the main complex of the house. Yeah, we didn't have any CSG back then, so
right.
It's not like we used it. So this is a cylinder that only has
three sides.
Yeah. Then there's another cylinder, which is the smaller one. That's another cylinder. That does. Oh yes, this is the nice part of the house.
The smoke and mirror side.
Yeah. Always. So this is the top of the house. We have a chimney here. It's actually named Chimney 1, which is just
and
a
the
cube.
2 is, I guess, the top.
Yeah, there's another cube. Chimney, another chimney. Yeah, that's just there.
Cool. Am I seeing undo in this tool, by the way? Is that how you're getting stuff back there?
That thing. That actually was a bug in one of our tools. And if you ever do something like this, I highly recommend you do this bug. So the way it works is while you are moving something with this, and you haven't let go of the left button yet, and you press the right button, it just snaps back to the original position, and then you can just let go of the left button and release everything, and it just undoes everything. And,
yeah, that's super nice.
So we had this. This was actually a bug originally in Edict 2, I think, or Edict 1 maybe, and we started using it unintentionally, and we got so used to it that we put it into the Edict 3 stuff that was actually used by some game artist.
Oh wow!
And at one point, one of the game artists came to me and said, "Damn you! I went to 3ds Max and started working and started pressing the right button to undo, and it didn't work."
Oh man!
So yeah, that's a really nice thing.
I just noticed you auto-saved, or your tool auto-saved at the bottom there.
Yes, it does.
Another good move.
We had to, and we also have crash saves.
Nice.
If you look at this, we have the ground bars for the thing set up.
Yeah, cool.
I was pretty meticulous about this.
Nice.
Oh yeah, these are clones. That's why they're moving that weird way. And these were cloned because then I only had to set up the texture once.
Right.
So there's these bunch of clones are those beams. Then there's another clone here for that's still the same thing, same stuff going. Another cube. Yet another cube. So it's basically cubes and cylinders.
Cool. Yeah, really fun to see this breakdown.
And hey, Citrus, you have some trees here. So yeah, this part.
Very nice. I really like those flat cornrows.
Yeah, and that's if you look at that, that's actually 2-layered as well.
Right.
For some reason, Zoom wouldn't know why that was.
Nia and I asked if this could be used for Krieger-like games.
We are not going to do a game with this. So what Farbrush did and what we did was they tried to make a game engine out of their tools, and both of us decided that it's not a good move.
After doing it the hard way.
Yes. But yes, it could be done. Also, there's another trick that we do. So for Krieger, what Rug and Chaos did was that they wrote a software that basically went through their whole source code. It was called Lecter, and it annotated their source code into a way that when compiled, it would output every line of code that was run, and then they just discarded the rest. And
wow.
And what happened was that the party version of Krieger couldn't go in the menu up by pressing the up key because during that round they didn't press the up key.
Oh wow.
And there is a better way of doing that. There are some things that actually do this automatically now, and then they can tell you what parts of the source code are not run. And if you have a deterministic run, like for a 64K engine, that's a very nice tool to have Just run it once before the deadline if you're above 64K, and you can just throw out a bunch of shit.
That's awesome.
And we did that. I don't know the name of the tool off the top of my head, but you can find some stuff like that. That's just another tip.
Fibo asks, is it a problem that this is actual geometry instead of SDF in terms of size, or do the basic shapes compress well enough? And I'm guessing the answer is going to be that these are basically described semantically.
Yeah, it's just, so if you have a cube, it's 1 byte for the cube and 12 bytes for the transformation matrix, I think, or maybe 24.
Yeah, so extremely small in terms of describing that. And then you just have, for example, the cube geometry is super tiny anyway. That's also packed in the intro. And then like a sphere generator, for example.
Yeah. So there's the material data, of course, added on top of that. But that's it.
Right.
And it's also
very small.
We have some optimization for the matrix export. So if the system realizes that it's a uniform matrix, then it will just put out like 1 bit.
Nice.
And also it can remove the transformation part, I think, and realize if it's like just an orthogonal rotation matrix, and then it can separate that as well. I think, at least I looked into it. Right, it was a while ago, so you can do stuff like that.
I can imagine a lot of wins coming from stuff like that, actually.
Yeah. Also, what we just did was that we check if a spline is like a constant spline, and then just output the constant value.
Right. Very cool.
Okay. Next question.
I'm actually really... Neonai says, do you store the projects in Git?
No.
I'm quite curious about...
Yep.
Oh, sorry, do you want to say something more about that?
No, we looked into actually working. So the XML thing, when I first started working on this, the idea was that yes, we could work, several of us could work on the same project at once, but we never really tried that yet.
Okay. Yeah.
So it might work, probably it wouldn't.
I see. So I'm pretty curious. One scene in here that I'm particularly interested in. I'm actually particularly interested in 2 scenes.
Okay.
Myself, just again because we're not getting any requests from the chat, so I'm just going to jump in here.
Sure.
One of them is the guy on the stairs.
Oh yeah. This one.
I really like this scene.
So as I explained before, that is just some vector graphics, of course.
Right.
Looks like this.
Interestingly enough, though, it does look like it's shaded.
Yes, because after you load in an image, you can of course post-process it in a texture generator.
Right.
It's just an input.
And so you fake the lighting there.
Yes. Well, zoomed it, but yeah.
Cool. And the shading on the wall there, is that just some more texture that's applied to that wall?
Yeah, there's 2 planes that do some darkening.
Cool.
And of course, again, the screen space reflections do the magic part. And if you look at it, it's actually really buggy here. But
yeah, it is.
In this way, it doesn't really show because it's hidden by all the post-processing stuff, the blurs and glows and the lens flare and everything.
Awesome.
If you notice here, the lens flare doesn't really show, but it's there, just a bit.
Yeah.
There.
I did actually. I've watched this intro several times, and I have actually noticed the lens flare there.
Oh, okay.
I really like how it looks. Again, because of its subtlety.
Yeah, this is the first intro where we actually did proper shadows. So the line you see back there is an actual shadow, and we also have shadows in the previously looked at scene. So here, those are actually soft shadows, and you have shadows on the house as well. We always faked those before, but you know, for this one we just did them properly.
Cool.
Well, properly. It's proper in the tool. You can just use it.
Yeah. The other scene that I really wanted to see here was, I believe it's that last one, Rupture.
Oh, yes.
This one. This would be really cool to see kind of a breakdown of.
Okay. So again with the weird colors.
Yeah.
So this stuff that you are seeing here, that's a very good example of subscenes. So there's one break probably. We are going to look at that. There's one break and it's just scattered around or placed down a bunch of times and animated once.
Cool.
So again, the inertial intensifier to just zoom into the scene a bit. There's the depth of field, the pellet, which is the magical post-processing stuff.
Of course.
I want to have a look at this, how this actually worked, because I'm not sure at this point. Oh wow, I forgot to do the go-to stuff for here, so we would have to find the old-fashioned way.
Okay.
Which is going to... So this is what I wanted to spare you guys. If you are looking for a texture without that, so you're working on your... working without the go-to function, then rupture X form, that's an X form. Rupture cars. I really don't know where that is.
I wonder if it's just the one called Rupture, just from what I saw in that list earlier.
Base. Well, no, these are for the model. Maybe Zoom can help us out. Or I will just try to find it here because that's a bit better. See how much pain I spared you guys? Burn Veton. Burn Man.
Awesome.
Maybe there's post palette. There we go, post palette. Yes. So
there's a question about why is there a wall on the top of the stairs in the last scene, but Zoom answered. He wants to tell you that it's a metaphor, but that wall is just there because the reference image that he used had it.
Yep, it did.
Cool.
So yes, this is the palette that we used for this.
Right, and that's just a basic color ramp.
Yeah. So you have these curves, and the palette just replaces the colors.
Nice.
And that is very, very powerful. So if I just change this around, you can see in the preview how well it works, and that is one of the strongest tools we have. So
yeah, really cool to be able to grade like that.
This is where we come back to how the tool is set up. This way of working, of being able to place anything anywhere and just being able to set up your own workflow without any constraints from the designer of the tool.
Yeah.
That is the key to our process, I think.
Yeah, I think that's really fantastic. Like, exactly as you're showing here. If you just want a color grading workflow, you can just put that together.
Yeah.
That's really cool. And Zoom points out that the palette is basically the same thing that a lookup table does.
Yeah, it's just that. So
as you mentioned,
it's very easy.
I'm pretty curious about the geometry, especially those cracks.
Okay, let's have a look at those then. I wanted to just finish this, so
Yeah, of course.
There's the glow, of course. Every time the glow actually has a threshold value, so you can just overdo it.
Yeah, you can make it look like 2004, or
yeah, you can make it like you look like a Qless demo. Inertial. So on this scene there are two inertial intensifiers. I'm guessing when Coupe or some other guy who is into actual proper 3D pipelines looks at this, his hair is going to fall out. Because that's very, so that's the strobe. You can see that very much now.
Yeah.
Yeah, there's just a bunch of shit. And again, another palette. So this is color graded twice. Because why not?
Typical. And I guess that map distort that's there is that 2D distortion that happens towards
which
the
map
end.
Distort?
There's a map distort beneath the glow. Under the rupture thing.
I have no idea what that does. Wow. We actually have, so that's basically probably the same thing as in the texture generator. We can try to find that again.
I don't think it's terribly important. But Zoom said the second inertial intensifier is a very subtle image shake that simulates old film.
Oh yeah, okay.
That's interesting.
I really want to have a look at this though.
No worries.
We have it, okay. Because I think this will be fun to see.
Cool.
Post distort, I just make this higher. So, wow, what the hell? That's not that. That is that, actually.
Yeah, I think that's a 2D image distortion that happens towards the end of the intro.
But why is it there? So that's just weird. It doesn't do anything, I think. Nope, it's just some... I don't know what Zoom wanted to do, but it never got removed. So we are not going to see some weird... well, we can just try, but no, it doesn't do anything.
Well, maybe go to the end of the scene, because Zoom just confirmed that that's what it's what breaks at the image at the end.
Okay, that's the part. Now it makes sense. Okay. Yeah, I'm not actually watching the stream.
Now I want to see when you tweak this. Yeah, that's cool.
Yeah.
Very cool.
Alright, so on to the animations. Let's see, just...
Yeah, maybe move the time a little bit first.
Oh no, we want to see it. So, this is actually a clip, of course. So what you have here is this. This is what you want to see.
Yeah, for sure.
And what you're seeing here, the thing that's moving, that's actually the shadow clipping plane. So the shadow is only rendered inside the yellow cube.
Okay.
And outside is just buggy. So
yeah.
Of course, again with the weird trees. I really like these cars. They're very small, but actually quite accurate.
And they look really good in the whole scene, even though they're really simple, apparently.
But from afar, they do look nice.
Absolutely, they do.
So what you have here, there's the ruptured line. This is what you wanted to see. So that's how it looks. And
oh wow.
Oh yeah, it's actually being stretched out as well. And I have no idea. Okay, so we will see some animation here for sure. So what you see here is the normal position, scaling, and rotation splines. And the ones below those are the things that are coming from the animated material stuff. So these are material parameters that are splines. So you can see the X offset.
The UV offset. Okay, yeah. So it pushes it out of the texture, I guess.
Yeah, we can just tweak this to see
that's cool.
How that will look without. So this is that part. And of course, the right-clicking stuff works. Right-click undo works everywhere.
Nice.
You have to have that if you are showing the stuff off. This is just scaling, wall color, wall UV offset. So the reason why you have a whole bunch of texture parameters here is that I think there's two models, two objects in the model.
Right.
There should be at least. So there's the base one and the wall one, and they have the animatable texture in both of them. So both of their animated parameters will show up in the spline list.
Very cool.
And you have to animate them separately, of course.
Yeah. So the crack here is made once too, and then that's composited a few different times and different rotations in the actual scene.
Yes. And then you have two models that actually do this whole thing.
Yeah.
And you cannot set the animation from here, so the phase that you are seeing here is the last set phase. So,
yeah. So how is this built here? So yeah, so we have the two planes because we have the base and then we have the other one, and they're just sort of by some noise.
So they are tinted. Both of them are tinted with the same thing. The wall is actually what is this? Seems like a plane. Yeah, this is a plane.
It's just subdivided.
Yeah.
And
the same tint is used on both of them.
Right,
it's just a noise texture, and there's a mapX form, and then there's some UV map. Yeah, so that's it.
Cool. Awesome. I really love seeing how some of these break down, just because, again, it's in cases like this, you see how simple the primitives are, but it's the way that they're used that's really creative.
Always, yes.
And I really am a big fan of that.
Right. Next question.
Those are the things that I think I wanted to see most. Okay, Noticing Limpet says, broad question, how different is this tool to ours? If you were to reproduce darkness in 64K, would you be able to do it in your tool? and vice versa to BoyC, for example, if you're doing Elysian. First of all, I know that your tool would be capable of basically all the stuff that ours has done. Maybe not some of the reflection stuff in our Engage intro, but definitely Elysian could be done in your guys' tool. I know ours would take a lot of work to be able to do something like darkness. Most of it would be hard-coded in textual shaders and just done by me with live reload on that. It would be a huge pain in the ass.
Yeah.
This tool is definitely a lot more advanced than what we're working with currently.
Yeah, what the whole thing, the whole idea is that we can actually work in the tool too. So when I'm experimenting with new materials or new rendering techniques, I just sit down here in the material editor and just start throwing shit together. So
that's great.
A bunch of materials.
That's really cool.
You just type, you press F5, and it just compiles and runs. So that's it.
That's fantastic. So I'm hoping to see if anyone in the as it just says challenge, make each other's intros in your own tool. I'm never doing that.
Nope. Wait, Citrus, do one of ours in yours, and then you can talk.
Zoom says, I think Elysian in our tool would be possible, but a lot more work because we still like a lot of procedural stuff for automation. Yeah, maybe. Yep. Who knows? So I think we passed the 2-hour mark here. So I'm really hoping to see if you guys in the chat are really curious about specific intros or specific scenes. I was hoping that this stream would be about 2 hours long, but I'm happy to go longer, especially if people have specific things that they want to see, or if you guys have, or if you boys have some more specific things that you want to show.
I think basically that's the gist of it.
I mean, especially even after seeing some of those breakdowns and seeing some more of these scenes, it's really cool. You can kind of project more how these are made, which I really like.
Okay, if there are specific ones that you would like to see, then there's this really interesting hack that we did for this intro.
The more interesting the hack, the better.
So basically, we had a problem with being able to set up the same particle system several times because it does take up a lot of data. And the hack we have for this one is, let me just find the scene, is that you have an emitter, and of course we have the forward kinematics everywhere in the scene editor as well. And what I did was that so the new this emitter has a shape. It's shaped like a sphere originally.
Okay.
And it's that one where the line is.
Okay.
What this does is anywhere you place anything that's parented onto this also becomes an emitter.
Okay, cool.
So
they make a bunch of dummies to place those there.
Yes, and then it's basically for free.
Nice.
And that's it. So that's a very, very neat little trick that we did.
That's really cool.
That can spare a bunch of data.
That's awesome.
All right.
Oh, and here the clouds, of course, is also particles. I wouldn't have guessed that.
Yeah, and if you look at this, these clouds take forever to because they're moving so slow, they start pre-calculating right here.
Right. That's so cool. Really cool stuff. What other interests do you have here? Just on
I think I have all of them.
Here.
At this point, there's nothing I cannot show intro-wise. So there's darkness, silence. We have seen those. Off-screen calling is super mode. There's the Deppy space, which is the first part of the silence trilogy.
Okay.
Which is just a very short one, so that's like we can go through this in a bunch of minutes. And yes, this is also before the linear workflow, so it's very bright here. And yeah, that's it. And I think this is composited together like this. So there's just that one scene, and that was copied onto a texture and then combined together. So that's
cool.
all post process.
I really like that. That's really cool.
Okay, then
I would really like to see the conspiracy theory too.
conspiracy theory.
Oh, did I say that?
Yeah,
Well, I'll stick with it. I'm just gonna own it now.
sure. Oh yeah. As you can see, the timeline is a bit more crowded.
Yeah, this was quite a fast-paced intro. I guess this was a lot of the cuts.
Yeah, a lot of cuts here. And we had some trouble with shadows here within the tool that has been fixed since.
Okay.
Basically, we had to turn off shadows for some of the parts so we could see anything in the tool. And then we forgot to turn them back on for the party version.
Right.
So the party version didn't have any... I really love that, the subtle blinking. I thought my phone was ringing because it has the LED flashing stuff, but it was only the stream.
Oh yeah. Yeah, you mean the subtle 0 and 1 there?
Yeah. Just a subtle
awesome.
blink. We're still waiting. So during the rendering of the music, we cannot actually play the intro, so we have to wait for that to render.
Sure.
But so what specifically would you like to see from this one?
I didn't really have anything in mind, to be honest. I just really like this intro.
Yeah, so do I. It was fun to do. Very stressful, but fun to do. The stress came from crunchy crashing on all machines but my home PC.
That's interesting.
And I had to say, so we did the intro, finished the intro at the party in complete secrecy. Everyone saw that we were working on an intro or something.
Yeah.
And we told everyone that we are working on a Digital Dynamite demo, and Zoom is just helping me finish it.
Okay.
And the problem was that I could only do an actual compile on my home PC. So I set up two ways of contacting my PC. Two different remote desktop solutions, and
Oh wow.
just 5 minutes before I left for the party, the internet went away.
Jeez.
The substation shut down, my internet substation, and we were very stressed because Zoom was actually an organizer, and if we were anywhere above 64K, we had to. We would have had to like jump in a taxi, come here, do the intro, while I actually stole one of the organizers, so I know what to cut. So that never ended up happening. The internet came back like 6 hours later, but wow, that was stressful.
Yeah, no kidding. Zoom says the greeting scene is probably one of the more interesting ones.
Oh yes, the greeting scene, which I still have no idea how he faked.
I'd love to see
Where is
this.
it? Here it is. So this part is fun because
And it looks fantastic.
because it's just a bunch. I think it's a bunch of recursive subscenes that you have here for the animation. So
Oh wow.
wow, yeah. Where is it? Oh, so yeah, this one, if you look at this one has a bunch of clips. So this is one clip that does the animation here. And so how this works is like you have like this bend light sub 2, which is this. It does that.
Right, and I guess this is the same kind of UV animation that happened with the cracks
Yes.
in the previous one.
Yes, of course. But the thing is that this itself is like a subscene,
Right.
a bunch of times, and I think that itself is like a subscene a bunch of times. So if I go there, oh no, this is just repeated a couple of times. So yeah, this is not subscenes anymore. It's just the model plays a couple of times, then that's repeated a couple of times, like that.
Yeah.
And of course, if you look at the animation, it will be offset. So see that how the timing starts there.
Right. Oh, that looks great.
And the other part that Zoom referred to is, I think that someone asked us how. Wait, auto saving.
It was me, by the way.
Okay.
Who asked this? How the depth of field is done on the transparent planes, right?
Yeah. That's just faked. I don't know.
Yeah, that was the answer I got, but I'd like to see it.
Zoom. It's basically some sort of.
Oh, is it this kind of blur?
It's actually the normal depth of field effect we use. So
okay.
I'm thinking that it's just set up in a way with the camera that. Okay, we can try to do something like this. I'm not sure. It's just fake. Basically, so it's just very, very powerful depth of field that it's blurry enough so you don't notice the difference.
Sure.
But basically, the ground plane is the thing that's being blurred.
Yeah, I think that's what I remember the answer was that the ground plane was the only thing that was actually emitting stuff to the depth buffer.
Yep.
And then that with the depth of field as a post process.
We can check that. I think we need to find the greetings part, which single greetings, of course. Everything is a single model here. So if you come here, this one doesn't have any depth writing. Yes.
That's cool.
So that's it.
Oh, it looks great.
Yeah, this is where Zoom doesn't know how he's supposed to use these things, and he just uses them any way he wants, and it just works.
It's the result that matters.
Yeah, of course.
And I think it speaks for itself.
Yeah.
But this is really great stuff. Does anyone in the chat have any more specific things that they want to see, or maybe we want to wrap this up soon?
Yeah, I think we can wrap up slowly.
I mean, I guess if enough people request more stuff, I wouldn't mind doing another one of these just to break down more of the intro-specific stuff. I mean, of course, if you guys are available, but I just think this is really cool.
All right, but I think we have covered most of it.
Yeah.
Oh, we have this camera shake event here that is now obsolete, because now we have other ways of shaking the camera.
Oh, nice.
And you have actual proper shadows here.
Yeah, that I remember. That looks really great.
All right.
Well, I'm not seeing anything from the chat. Other than Citrus points out hammer time.
Of course.
No signal input says, can we just see the red part? I don't know what he means by the red part.
Oh, the red part. I think I know.
Yeah.
This part, right?
Yeah, that's probably it. A lot of crazy stuff going on here.
Yeah, this is the classic chaos theory stuff.
Yeah, I would really like to see, especially the geometry here. It could be cool.
Okay. So again, keyframer. This is okay. Let's just do the breakdown first. So this is how it looks like.
Yep.
Suddenly it runs at 45 FPS.
So this is like in Chaos Theory, and I guess this one as well. I guess a lot of this stuff was originally basically black and white, and then a lot of the color stuff is added after.
Yes.
And that seems to be the case here.
We can look at the whole intro like that. So yeah.
Seemed to be the same formula more or less.
Yeah, basically it took the tried and true. Yeah. So there's
Neon, I actually asked a question here. How does a compiler look like for an operator? So, for example, in the texture generator, like if something doesn't fit together, or is that just not a case that you guys have issues with?
Compile error? We don't have compile errors. Okay.
So, or rather, like an invalid operator graph.
Okay.
How would that?
Yeah. So the way that looks, so all operators have a fixed number of inputs, and if it doesn't have the required number of inputs, it just shows like that red bar.
Cool.
And then on export, then it says that you cannot export this because you're doing crazy things.
Right.
And that's that. So if I now place like 2 operators here because it needs 2 operators to work, then you just get that.
Nice. CBDT asks, is that per object motion blur on the chain things?
I don't think so. We never did per object motion blur.
I guess there's depth of field that's blurring the
Yes, that's depth of field.
thing there. Yeah.
No, there's actually motion blur there.
Okay.
But our motion blur only works for the camera.
Okay, cool.
So I'm guessing if I move this camera shake around after the... Actually, I don't know. The camera must be moving as well. So if I do this, so now I removed the animation from the camera and everything, and the motion
now the blur's gone.
Yeah.
Cool.
So we don't have per object motion blur. That's on the to do. We do want to have that. So yeah, but everything is grayscale again, mostly, and it's all in the post-processing chain. And then we can go into so motion blur, texture draw, which is just a tinting stuff again. Inertial intensifier again. Glow, really overdone glow. Lens flare effects for some more glow. FXAA, I don't know why. Another inertial intensifier. Strobe, film grain, sharpen, because it actually works very well with this film grain.
Yeah, it really does.
And then it's blurred again. So chromatic aberration, the vignette, and the must-have palette.
This is awesome.
So if we go into this, keyframer, yeah, that's here. There's a bunch of things going on here. So we have a sky sphere for the background, which is just it's not really a sky. It's not really a sky sphere. It's just a bunch of planes thrown together.
Cool.
This is what you want to see, I guess. It's called Chaos Snake or Chaos Worm. There's a camera. There's the strobing stuff.
I'm guessing the animation on the Chaos Snake is probably UV.
Yeah,
again.
It's of course it's UV.
A lot of mileage on that.
Yeah. The conspiracy logo actually is a bunch of UV animations.
Oh, so really?
That standard that we have used for a couple of intros now. That's it's the same UV animation.
Cool.
UV. Yes, the UV goes up to 11. And yes,
no breakdown is complete without a Spinal Tap reference.
Yeah. The thing is, so by setting the size of the length of the event is how you set the 0 to 1 value. So that's where that happens.
Cool.
So at the start of the event, it's always 0. No, it's 0. It's 1 here, but it gets fed into the time envelope, which is it's mostly at the default settings. So.
As Zoom points out that actually using a slight sharpen and blur is a nice VHS-like effect for the object edges.
And there you go.
Good to know.
Yeah, the more you know. So I think we want to have a look at this. We are not going to see much here because it's black. It's completely black. But let me just do something for the background. Maybe? Why isn't it growing? Oh yeah. Random texture. Random texture. Just change the culling. So now we actually can see something. Let's pick a separate texture. Palette. Okay, so now we can see something. So this is how this thing looks like. It's basically... Oh, wow, it's a bunch of clones as well. I never knew that. So you have loft. The loft is, of course, it's made of 2 arcs. So if I were to increase the resolution of these arcs, then everything would just increase.
Cool.
And there's another arc, which is just, for the cross-section. It's basically a torus that was tinted like that.
And then some displacement, I guess.
Yeah, mapx form, smooth group, UV map, another tint, another mapx form. So
cool.
I can just, if I disable this filter, so I'm guessing that is for the cross section. So that's the minor. That's the detailing goes on later, and waiting for the autosave. Okay. So if we remove this as well, then you get a torus, and I'm just so what we are seeing here is that there are two of these. So if it was copied and redone with some different values.
Cool.
So now if we go to the video editor, we're going to see some weird shit. Just delete this cube.
Right. Oh, that's so cool to see.
That doesn't look half as bad.
And the CBDT points out that the loft operator looks insanely useful.
Yes, it is, and it's very easy to do.
Cool.
I can go and get a bit more into that, so you guys can see the way that works, because that is something that we have done for a very long time now. Basically, so you have an arc here, which doesn't show up again, but so that's the arc. It's on the blue-red axis, so that's like the XZ axis. And we are only taking that part into account. So the way this works is we have two paths like that, so at least for the cross section. And you can do another arc or whatever. We don't have the splines working yet. That's one of the next things to do as well. So what you have here is when you do the loft, you select the path you want to use, and you select the cross section, and put on some material here. Maybe we have a wireframe. Yeah. So we show this properly. So what you have here is now the position of the arcs describes where these should be. So this is the path arc. I will just rename it path. If I scale this, then the cross section won't scale with it, but the actual path will scale. And if you do weird stuff to the cross section, then you can do interesting things here. And there is one. So this is all 2D, but if you start doing weird shit like zoom can do.
Yeah, like rotate. That's what I was gonna ask.
If you rotate it out of the plane, then you can do some interesting stuff.
Cool.
Of course, it can break. But, There's another thing that we rarely use, but that's included here, is that so you can close the path and close the cross section, of course, if you need to. There's a start scale and an end scale, so what you can do things like this.
Ah, cool.
That's never really been used, and we also have a rotation value that hasn't really been used.
So cool.
So yeah, those are the lofts. They are insanely helpful. And
yeah,
of
definitely
course,
seem to pull a lot of weight in your guys' intros.
What you can do with this is like throw on a tint on the path, or not the path maybe, but the actual cross section. So you tint it, and then of course mapx form it.
Right.
And if it would work, it would be great.
Do we need to tint it with a texture?
Texture needs to be selected. Whatever, maybe we have some cloud. And then yeah, you can actually do even more interesting things. So it's, as I said, it's basically an operator stacker, just limited in the UI.
Very cool. Oh, this is really cool stuff. I think Neil and I also asked in the shader editor, what does it look like if there's a syntax error?
Oh, okay, I can show that to you. Syntax.
He also asked if the chaos snake was a single operator, but I think we've answered that with showing the law stuff.
Yeah. So we have the, wait, let me just get, these are some really easy shaders. So you have an error here, which, yeah, this should be
comes out on the console there.
Yes, we have the actual output.
Cool.
And I just found a bug. Nice.
Cool.
I recently did this docking UI where you can just, you know, take a window and dock it.
Yeah.
And the docking UI, for some reason, killed that part. Now it works. Weird. Okay.
Huh, that'll be fun later.
Yeah, I mean.
Citrus asks, how do you draw lines?
What lines? For the wireframe?
I bet he's talking about in the demos, particularly in that Chaos Snake scene, there were some, like, lines going through, but I would guess they're, like, billboard kind of things.
Let's see.
Oh, no, he actually does say the wireframe.
Wireframe? Look up geometry shaders and wireframe and line rendering.
Well, I'm curious about these lines as well, so.
But the wireframe is done in a geometry shader and it outputs, and the drawing mode is set to line, I think.
Cool.
No, that's not right. I did actually draw proper geometry from geometry shaders.
Okay.
Yep. Okay, so these ones. Flashy 2. I think that's just a bunch of planes, maybe?
That's what I would guess.
No, it's actually a loft. There's a loft here.
Okay.
That has been distorted to hell.
Good.
So if I disable this and put on a normal texture.
Cool.
Yeah. So that's it. It's a poor torus.
It was a Taurus.
Yeah.
I like this. Neil and I also asked, what does your color picker look like?
The color picker, it's just RGB values. So that's something that I wanted to discuss with Zoom, but he's content with that.
Okay.
So whatever, if I want to do a colorize, then you just set them like that. What Zoom specifically asked to include was this portion in the bottom left, which is that if I press Shift anywhere, we have a color picker like that.
Oh, that's cool.
That we also had that for Edix3, and it's very handy. And this also translates, so it shows you the actual RGB values and the linear RGB values as well.
Ah, nice.
So
very nice.
That's very useful.
Does that inverse gamma correct, I guess?
Yeah.
Really cool. Well, we just hit 2.5 hours.
Wow.
And I think this is probably a good time to
all right,
to cut this off. I want to say, first of all, thank you so much for coming on and doing this. I was really excited about this, and it's always been cool to,
this is fun.
like, I mean, I've seen screenshots of this tool for years, and it's really cool to actually see this and see some of the intros broken down. So, again, thank you so much for doing
You
this.
never came up to me at revision.
What was that?
You never came up to me at revision, so I could.
No, I think I was one of the few that didn't.
Yeah.
But I definitely will at some party coming up. Definitely want to see more of this stuff. This is really cool. But yeah, thank you again so much for doing that. Thank you everyone for tuning in and watching this. I'll have the video uploaded in, I think I'll have it out in a couple days. Just thanks for the stream, even though you didn't show me the grass. Oh, that's funny.
Which grass? What? Oh, sorry. That was Titus. Yeah.
Yeah, I don't recall. Anyway, yeah, just thanks. This was really cool.
Yeah, this was fun. Yeah, and if anyone has questions, just, in the comment section below.
Yeah, absolutely. And you can find, of course, all of us on Twitter, and I mean, I guess most of them are going to go to conspiracy Twitter in this case, but
yeah, we'll see.
Anyway, really cool stuff. Thanks, guys, again, and I guess I will see you next time.
Bye, guys.